I wonder what that could be. Oh my god. It's a package. How could I not have realized? Hey guys, welcome back. Today we're going to be reviewing the Gigglebot. Gigglebot is basically a robot, as you can see, that is comparable to the LEGO Mindstorm's EV3. The LEGO Mindstorm's EV3 is also a robot, but it's more childish and less complicated, if you will. This is a step up. So if you're wanting to get into robotics and you just finished off with the LEGO Mindstorm's EV3, you might think about moving to this. Now, if you have a LEGO Mindstorm's EV3, you know those are quite expensive. At least $400, $300. But this one, not so much. It's somewhere near like $60. It's not very expensive, but when you do buy it, it comes with all of this stuff. It doesn't actually come with this. This has to be bought separately. But Dexter Industries was nice enough to send both the microbit as well as the body. Now, it may look like a very childish and cheap, not very good robot, but it's actually really interesting. May not look, when you look at it, you may think, oh, this is small, probably can't handle a lot. Maybe just switch on some LEDs, move some motors, that's it. But no, it can do a lot more than that. As it'll be shown in the video. It'll be shown later in the video what this can do. But we'll start off with looks. Now, when Dexter Industries made this robot, from all the branding and stuff, it seems to be in the shape of almost a frog, I'd say. As you can see, when I switch it on, you can actually see the lights on the bottom. That's in shape of a U, indicating a smile, and these two lights, which are supposed to be eyes. So yeah, the design of it is pretty good, and yeah, as I was saying, you can do really cool stuff. I programmed this currently to move the lights and display something on this dashboard. Yeah, it's also powered by 3 AA batteries and moves using 2 motors. Now, I do feel like this is just a little too stuck out. It's just the whole body is kind of flat and sleek, but then you just have this huge bump. So if this was more flat and lower towards the ground or the level, it might have been a lot better and helpful for more people. Because right now, if you're trying to take this to a small space, you can't really do that. Because let's say the height is around here somewhere. If the shape was lower, it could have made it through. But this is the highest point in the body. If we didn't have this, all will be fine. It can go to really small spaces. But this is basically the processor. This is what's behind the computer. Computers you have, this is basically everything you can see, your OS and everything, but this is everything that runs it. So this is a very crucial part of the Gigglebot. Now the wheels, they are pretty solid. Like they don't like crumble or slowly just kind of fall apart. They don't seem to be doing that. They're strong no matter how much pressure you put on them. Not just for the wheels, but the whole body. Like it is pretty strong and rigid. It can survive a small drop, not too much, but again, not a lot of bots can handle those. Yeah, another thing I don't like about the design would be the wires. They just seem to be coming from here and here. If you had maybe like taken them on the sides through the poles, or like hollow poles that go into this, that would have looked kind of nice. And this, you may be wondering what this is. Now this is the thing that it has the sensors on it. As you can see, these are the individual color sensors. These, so basically what you do, if you keep it downwards like this, like it's supposed to, it can usually just scan the floor and detect the color. So that's what those this whole bottom part is for. Now you also have the part that I really like about this robot. You wouldn't even know there are light sensors on it. It doesn't seem like that, but if you look right above the LED, right here, you can actually see a small thing. That's the light sensor. Now, I'm gonna ask a quick question for Dexter Industries. I was wondering if these affected performance. Now that answer might be shown in one of our experiments that'll happen later on, but yeah, they seem to be functioning just fine as I use them, because they're facing upwards. They're not facing towards the LED. If you have like a mirror or something, it'll probably affect it, like right here. So the light from the LED hits it and goes back into the sensor. But otherwise, it's pretty good. You have your sensor pins here for additional sensors, and here too from servo motors and additional motors. Yeah. Now, a cool part I like about this robot as well is this. This is called a microbit. It's made by BBC, the guys who made Planet Earth 1 and Planet Earth 2, you know, those documentaries, and also news. So you can see it's really pretty cool. You have all these. It's so small. Like you'll probably underestimate it, but like this is my hand, and this is the actual processor. Now it can handle quite a lot, but you can see it has compass, accelerometers, and a few other sensors embedded in it too. Now it also has an LED display on the front, so all of this, depending on what you want, you can actually make them light up. So as you saw earlier, I said hi guys, so we went, each letter went individually through each LED. Like that's called a string, for what those of you want to know. But we'll get to that when we get to the coding section. The motors in here, they're also pretty good. So they're powerful motors, since you have you have this motor here, and then you have all this yellow part. Inside this yellow part, there is gears. These gears basically make the motor more powerful than it actually is. Because if you just connected the motor up to the wheel and try to make it spin, it wouldn't be as strong or as powerful as using this. Now, you do not want to move these like this, because it kind of starts to damage the motors and the connections. But yeah, it's pretty good. Another thing I didn't like though was this part. It's very loose. You can hear it rattling in there. It just doesn't sound great. It feels like metal, solid metal, but to me, it doesn't feel like good enough. It's not. It doesn't feel like it's supposed to be there. Although it does seem to work fine, except if you're using this on, let's say, wooden floor or carpets, it really won't move. It'll just be these two taking most of the grunt of the force. Yeah, that's mainly the looks of the robot. Yeah, but as you can see, you only need 3 AA batteries to power this. So that's good. It's pretty power, saves a lot of power. Unlike other robots where you need a lot of batteries and you need to replace them pretty frequently. But now let's get on to coding. Now what you want to do is you want to take a micro USB cable, is the one seen here. This one. And there's a slot on microbit. Now you can just take the microbit out. You don't need the robot body for this. We'll just keep that aside for now. So you take the microbit, look at the top. There are 2 ports. There's a port where you got the battery pack, which I'm not showing currently. And there's also a micro USB port. Now what you want to do is take your micro USB and just plug it in. And on this side, that's all you need to do for now. Now you want to take your USB cable side and plug it into your computer. The next part is on your computer. Hey guys, so this is the coding part of the Gigglebot. What I want you to do first is go to gigglebot.io, as you can see. Wait for the page to load. Okay, so now we're here. This is the Gigglebot site. Now go to Start, click it, and scroll down. At the bottom, you'll see 3 languages: MakeCode, MicroPython, and EduBlocks. Now, if you're moving from a novice coding, I would recommend MakeCode or EduBlocks, and if you know how to code pretty advanced, use MicroPython. For the simplicity of it, I'm going to use MakeCode or EduBlocks, but out of the 2, I prefer MakeCode because of the better interface. So just click Programming Robot and MakeCode. Scroll down and click the Open MakeCode here. Try to make sure you're using this in Chrome. That's what the Dexter Industries recommends. So now wait for the site to load. So this is the site. So what you first should do is you want to go to Advanced, Add Package, search up Gigglebot. Okay, now click Giggle, and it should install. Now I've already done this, so it has my 3 packages. So this is the code we're gonna write. I will just show you how to write it. So let's just delete it right now. 1 and 2. Okay. So what I want you to do is go to Gigglebot. This controls the motor functions of the Gigglebot. So if you hover over a block, it'll tell you the specific, or what it does, the specifics of it. And it'll also tell you the Python code. So just click it and drag it over into forever. So forever is basically a loop, and on start it only does it once in the beginning. So now next part is go to lights, hover over it, read it, cycle rainbow 3 times, and now put it down. Now try to make sure it's cycle rainbow 4 times and not 3 times, and 4,000 milliseconds. This is just personal preference, but you can really do whatever you want. And a nice thing I like about MakeCode is that on the side you can actually see what the microbit is going to do. The other one, EduBlocks and MicroPython, can't do this. So now let's change it to SNL, the name on the bottom. This stands for spin and lights. Now click download, done. Now you should see a microbot sl.hex. Open your Finder. Now you'll see in your downloads bar you have microbit sl.hex, and you can also see your microbit on the side. So take your microbit.sl.hex and drag it over to your microbit drive. And drop it. Now on the side it should show you just copying microbit sl.x to microbit. It's just copying the file over there. Now you can see it's gone. After you upload a file, the microbit will automatically eject itself. It'll say this not ejected properly, but that's fine because the microbit is doing this and you can't really control that. That's all you need for this part of the coding. Now you're done. So let's move on to running the code. Okay, so now after you've taken your microbit and uploaded the code, you also have your other side. You want to unplug this from your computer. Now just take the micro USB out of the microbit like so, and just put it aside. You will need it later. So you want to take the body and just mount the microbit. Now make sure the lights are facing towards you. Where the two LEDs are, the eyes, you want the two buttons to be facing them as well. Otherwise it won't run properly, or that's what I've encountered. So now it should be ready to go. Just snap it in place and it should be ready to go. So let's try it. So to switch it on, just press, there's a little switch right here, right next to the microbit. It's on the off position right now, so just slide it, and it'll start. So this is the code where we have to spin in the same place. And after it's done, it will start the lights. See? Stops, and the lights start to fluctuate. Starts again. Stops, lights start to fluctuate. So keep doing that forever. Now basically it's kind of hard to get this back in control after it starts spinning. So just when it stops, just grab it, let the wheels roll like so, and just switch it off. Okay. Hey guys, thanks for watching. Really appreciate it. This is my first ever review video, so I hope you liked it. I don't think it was that good, but it was fun making. And huge shout out to Dexter Industries for sending me the robot and the microbit. You should definitely go check them out. I believe all the links I use in the video in the description. And well, I'll see you guys later. Bye.